Our guest today is an author, scholar, and adventurer who loves gaining new perspectives. After graduating high school, she enlisted in the U.S. Army, where she rose from the ranks of private to captain, during which time she was recognized as a distinguished military scholar. She worked as a communication expert at the South Pole Station in Antarctica and has served as a Russian translator on board Soviet trawlers on the Bering Sea. And if that wasn't cool enough already, she's gone from absolutely hating science and math, flunking her way through those courses in high school, to eventually earning a PhD in engineering. She's published in some of the top journals in her field and is an elected fellow of the American Institute for Medical and Biomedical Engineering. Her research focuses on the fascinating and complex relationship between neuroscience and social behavior and has been described as revolutionary in the Wall Street Journal. She's published in outlets as varied as the Proceedings of the National Academy of Sciences, the Wall Street Journal, and the New York Times. She's also authored 10 books on topics ranging from the negative aspects of altruism to career development in bioengineering. If you're one of the 2.7 million people who have taken her course on Coursera, you might recognize her as the instructor of the world's most popular online course, Learning How to Learn: Powerful Mental Tools to Help You Master Tough Subjects. So please help me in welcoming our guest today, the New York Times bestselling author of A Mind for Numbers: How to Excel at Math and Science, Even if You Flunked Algebra, Dr. Barbara Oakley. Dr. Oakley, thank you so much for taking time out of your schedule to come onto the show. I really appreciate you being here.
Oh, it's my pleasure, Harpreet. Please call me Barb.
Oh, definitely, Barb. Well, Barb, so talk to us about the type of kid you were in high school. What did you think your future was going to look like when you were in high school?
Oh, gosh. That was a bit long ago. Too long ago I'm a little embarrassed to admit how long ago it was, but I remember my chemistry teacher, for example. I was flunking chemistry, and my parents were like, go in and talk to him and see if, he'll explain some of these things. And I remember going in and I was almost belligerent, sort of like, I dare you to try and put it in my brain, because my brain just is not going to learn it. And of course, I didn't want to learn it. And so I was not making it easy. I was one of those just rotten adolescents. And I almost have to laugh now, because I was just convinced that there was really no need for math or science in my life. I remember being called into a dean of students when I was in eighth grade because I just read books during math class, and just I really remonstrated and just said, this stuff is useless and I won't need it. And yes, you can get through life without math and science, but you can also get through life if you just eat, rice and beans and very plain food. And it's not nearly as colorful or wonderful a life as it could be if you embraced it with everything that was really truly available. And I didn't understand that learning math and science helps open all career doors for you. Whereas without at least some background in those, it really closes off the opportunities that you might have. And so, but fortunately, it is not like something where if you don't learn it when you're young, you're just shut out forever. I started learning remedial high school algebra when I was 26, when I got out of the military. And it wasn't like it was easy, and it was scary and intimidating, but still, just by slowly and persistently continuing on with the studies, success eventually came my way.
And what was that journey that kind of led you towards wanting to cultivate this understanding and mastery of mathematics? Because you went from hating it to getting a PhD in engineering, which is pretty much all math and science. So what was that transformation like to to want to pursue excellence in this area?
I think reality can be a hard teacher. So for me, just getting out and then seeing my friends and colleagues in the military who were West Point engineers very easily getting jobs, and I, with my bachelor's degree in Slavic languages and literature, well, no one was looking to hire someone with that kind of expertise. And I just didn't realize that by following my passion, which is what everybody told me to do, I was actually selfishly putting myself in a box because I wasn't also looking at what the world's needs were. And also, like, I do like adventures. I do like trying new things. And so when I suddenly began to realize that, wait a minute, learning in math and science is as much of an adventure as going out and working on the Bering Sea or at the South Pole. Why don't I see if I can open my mind to that? That really having that kind of attitude about the potential in the field really helped change my mind. But I think the biggest thing was just seeing that the exciting jobs that I was looking for were not open to me because I'd closed myself off to learning about careers or the background you needed for careers in math and science.
So when you kind of think back to those days when you're forcing yourself to this transition of wanting to get better at math and learning it and convincing yourself that you can learn it, what was that like? Like, did you first have to understand that actually I can learn things? The brain is plastic, it's malleable. Like, I guess what kind of came first, your interest in the brain and learning, or were they kind of hand in hand?
Well, I think what happened was I was lucky enough to study Russian at the Defense Language Institute, and they have devised methods for teaching language that are very successful for a wide variety of languages. And it's certainly not going to make you, you're not going to go there and a week later walk out to be a native speaker like person, speaking in Farsi or something. But it's about the best we know of to help you learn efficiently in any language. And so what I did was I applied some of those same techniques that I'd used to learn language to learning in math and science. And I didn't realize that there's actually, I didn't realize at the time that there are deep underlying similarities between learning in language and learning in math and science. And for some important parts of learning in math and science, you need that procedural fluency. You need that interleaving. You need a lot of the different approaches that are used in teaching language. So when I applied those kinds of approaches, I could make breakthroughs in understanding that I could never make when I was a younger person.
And I'm definitely excited to get into some of these techniques that you talk about in your book, A Mind for Numbers. I really, really enjoyed that book. In fact, I've got it on the bottom rung of my bookshelf because when my son is old enough, I want him to be able to easily grab that book and pick it up. Because I wish I wish I had learned a lot of this stuff when I was younger. I think it would have made for a much more rewarding period of life in my 20s and in high school. But before we get into your book, I love the quote that you open your book with, um, the law of serendipity. Lady luck favors those who try. Talk to us about, I guess, why include this quote and what does serendipity mean to you?
Well, sometimes my students would ask me, well, what particular problems should I study? And let's see, I think, and that's a very important and good question. And the essence behind the answer to that question is, what are the nugget kernel problems that you really want to internalize so that you can see them in your sleep practically. You understand every facet of them. And what I was really meaning by that expression about Lady Luck is that sometimes people are so agonizing about which problems they should study intensively that they don't do any. And so what I'm trying to encourage people to do is to just start. Just pick a problem that feels like it might be an important one and really internalize that problem so that you're not memorizing it. Instead, you can look at the phrasing of the problem and know it so well that instantly in your mind you can step through all the solution process for that problem. And so I'm just encouraging people to get started in really knowing some aspects of what you're learning well. And it kind of doesn't matter if you pick problem A versus problem C or problem J. It's simply a question of internalizing some of the main idea problems.
I like that a lot. That's completely different than what I had thought it would be. I've been studying luck recently in the last few months. I guess it's just I go through these phases of intellectual curiosity, one of which is luck and serendipity. So I've read quite a few books around this topic. I'm trying to deconstruct what luck is. So I'm just curious, like, what would you say your relationship with luck is, and how have you managed to create your own luck in your life?
I think that's a tough question because sometimes students will come up to me and they just want to know the answers so they can or they just want to get a good grade in the course or a decent grade. They don't really want to learn the essence for love of learning of the material, and that's perfectly okay. I mean, I've had teachers I didn't like with subjects I really didn't like, and I just kind of wanted to get through them, and it worked, and it's okay to do that. But I think that when you are luck has played an enormous role in my life. I could very easily see that I could have become a server at a restaurant, and I would have been a very bad one because I don't have a good working memory. And I was a server I was a waitress at a old-fashioned restaurant. It was Victorian home and everything, and I was so bad that when I went to give my notice, they said, "No, Barb, it's okay. You don't need to give us your 2-week notice now. You can quit right now," because I was well-intentioned, but I would just keep forgetting things. And so, I can easily see in all sorts of different quantum universes, I would have gone in very different directions. But I think in essence, by always following my own lodestar of what I've been interested in, it has accidentally created all of these opportunities. For example, when I got interested in why mean people do what they do, not psychopaths, but sort of like, your coworker who has been really nice for a couple of years, and then you find out that they've been stabbing you in the back all the way along. Why would anybody do something like that? And that's the kind of question I became interested in. And so I thought, well, gosh, I'm an engineering professor. I should be able to understand the psychological literature about mean people. Well, I found out, when I really researched it, that pretty much all the psychological literature on that phenomenon was based on thin air. there wasn't any solid scientific research. It was all just people citing each other in the psychology literature, but nobody had actually done any genuine fMRI studies or anything like that. So I became very interested in this problem. And here I was trying to get tenure. And, my father's dying of Alzheimer's. I have a young family. And every little minute that I could, I'm trying to research this problem of mean people. And I did this for 6 years in a corner. And I'm like, who's ever even going to look at a book by an engineer, not a psychologist, but an engineer on on what's going on with this phenomenon? But I was really curious. And so I just kept on it. And it turns out that, of course, that laid the foundation for my later work in pathologies of altruism and even in education. But I think it's that, what laid the foundation for all this luck was always being willing to really delve into something when I got really curious about it and look at it from first principles, not just like when I'm looking up altruism, I didn't go reading all these books on altruism. When I'm trying to look at pathological altruism, it's misleading to look at the work on altruism. There's so much of it, and much of it has nothing to do with what we understood of the brain from science. So you had to kind of go back to first principles and look at things yourself. So I think being willing to go back to first principles and think independently and work in a corner all by yourself, but still be willing to have people look at what you've come up with because, they can shoot legitimate holes in things. All of these have helped underpin the luck that has manifested in my life.
I absolutely love that. I think that's very that I love. Like it's like you follow your own obsession and you study things that are interesting to you, and that allows you to kind of connect the dots between things, and maybe you start finding the intersection between topics that you find interesting, and then you combine them and come up with some research or some new type of work addressing that intersection, and you just create more opportunities for yourself to collaborate with other people and things like that. I think that's really fascinating. So I was one of those students back in the days where I just wanted the answer. I just wanted to know, you know, the answer. Wasn't really too. I didn't really care too much about internalizing stuff. I had my slogan in undergrad was C's get degrees. And
but what's that one that the A students end up working for the C students?
yeah,
There's to that too.
yeah, right. But I feel like I was limiting myself in that way, right? So I guess this kind of leads me to the question of self image and self perception. So what role do these two play? Like what role does self image and self perception play when we're trying to learn something new or maybe even advance in our own field?
That's sometimes I think high self-esteem, especially in learning, is really overrated. Most of the things that I've been successful in studying or learning or making breakthroughs about, I've felt like the most deeply inadequate person around. I'm like the village idiot who comes in and, but wait, I don't understand this basic concept or this foundational thing. Well, sometimes it turns out that's actually that everyone is taking for granted this basic concept, but actually it's erroneous. So sometimes when you're coming in as a fresh person who's the village idiot, you can see things that you cannot see if you had been trained in that discipline. So I think for me, a big and a key idea has been in growing comfortable with feeling uncomfortable in whatever I'm learning or doing, and that it's perfectly okay to be the village idiot. Although, you don't want to like slow other people down all the time because you can't even get to first base with what's going on. You've got to go and learn on your own, as well as interact with others. But um, your freshest work will almost inevitably involve things that you feel like the village idiot when you're trying to learn it.
I, for one, love feeling uncomfortable and I love feeling stupid because that means that's an opportunity for me to go learn something new. And that's just such a rewarding feeling, not knowing something at first. And then you look back like 2 weeks later, like, look at all of this stuff that I've been able to figure out. I started off just completely confused. And now, like, look at me, I can kind of talk with the best of them about this topic.
I do it to say that sometimes my C students were the best students. They're the ones who would come back to me years later and say, I won the Boss Kettering Award at GM for my creative breakthroughs. Sometimes A students are really superstars and they can break through on other things, but sometimes it's pretty clear that some A students are more interested in the grade, and they're willing, they want to henpeck you about the details just to get a slightly better grade, but they're not really creatively thinking about the material. And C students are they can be much more likely. And also, it's like they don't care so much about the grade. And so they might be just learning it a lot better because they're not like just doing it for the test.
Yeah. I used to be in a profession. I was an actuary for a while, and that profession required me to take so many exams, and I just could not. I was just done with that. That was so stressful for me because I'm not like the best exam taker. And I felt like I was learning the material, but having to then sit in like this stressful environment where it's 3 hours, it's just you, quiet room, having to take this super stressful exam. I just was like, I did not want the rest of my career to be like that. Um, but you made an interesting point in your book about following your inner passions. We are just talking about that before, and how if you follow your inner passion without being open to developing new ones, you felt like you're pigeonholed. I think this is common amongst data professionals in a different way. There's such like a huge push for everyone to specialize in one aspect of this profession or another. I'm wondering, do you count specialization the same as being pigeonholed?
Well, if you're being paid well for it, that's one thing. That's slightly different than. I mean, in essence, the idea is similar. You have one job ability that you're really good at, but it's really nice to have a job ability that you're really good at, that you get paid for, as opposed to a job ability that you're really good at that nobody really wants and you can't get very good pay for. As they often say for writers, basically do not quit your day job. And so it's a wonderful thing to have a good profession like that. And that's not to be discounted. But I do think that it will make you a happier human being if you also are dabbling on the side with completely different things. Like, I don't care what it is, whether it's studying Sanskrit or learning about photography or any kind of thing that's really different. But there's plenty of evidence that learning new things, and I think especially that means learning new and different things, helps with neurogenesis. That is the growth of new neurons. And these new neurons help get you out of that rut, because it's new neurons that really help with your learning, not the old neurons so much with stuff that you've already learned. It's the new neurons. And so when you're learning new things, the new neurons like have a reason to hang around. And that actually has been affiliated with feeling better. In fact, some forms of cancer therapies they have been shown to cause depression in large part, it seems, because they stop neurogenesis. So anything you can do to help encourage the growth of new neurons, and of course that's exercise, getting enough sleep, but also learning new things that are really different, can help you feel better.
It's a very interesting point. I spent a significant portion of my professional career, about 5 years of it, as a clinical trial statistician. I was a biostatistician for a while, and every day was essentially kind of the same type of work. Like there wasn't much variety in the type of work that I was doing. It's, writing protocols, writing statistical analysis plans, and my life at that time, I wasn't doing anything different or anything new. Fast forward a couple of years, breaking into data science and then having to learn all these cool new technologies for data science. It's just made me feel so much happier, so much more excited. And just this last, in 2020, last year, doing stuff that is completely outside my comfort zone, like creating a podcast and then doing all the promotion that comes with it, the graphic design for blog posting and waveforms for podcast promotions, things like that. Completely different than what I'm used to, but it just made me feel so much more happier and so much more just, I don't know how to describe it. Like I'm addicted to creating new things now. It's been fun. I really, really enjoy it. But
And,
yeah.
and it's so different from that very closed in, you're typing something. Instead, you're talking with others, you're learning about the technology involved in microphones that work and those that don't. But I think that's one of the things I really enjoy too about writing, is reaching out to other researchers and talking with them. I think what you're doing with podcasting is just such a thrilling way to help us all. And even listening to podcasts can just open whole new worlds through the conversations that you have with others, and then we get to listen in on. And yeah, I can definitely see that both what you're doing as a podcaster and what we're doing as audiences of podcasts all help to contribute to broadening our horizons and just making for a happier sense of self.
Yeah, it's the coolest thing to be able to just like talk to the authors that wrote books that you found interesting, that have inspired you and helped you, and it just reaching out to them, and they're just nice. Like you're so nice. You just said, "Yeah, I'll come on your
Oh,
podcast."
my husband will tell you I'm a grump sometimes. He's insane.
Yeah.
So, have you thought about writing a book?
Um, I tried to dabble with blogging a little bit. I went on this like 3 week, like, I want to say writing binge, where I had developed a framework for persuasion called the EPIC framework for persuasion. That persuasion is empathy, perspective taking, influence, and concurrence. And I was like starting to write that out, but then it just felt like it was like a research paper, like a really academic research paper. And I kind of took the foot off the gas for that. But I've pivoted more towards writing online courses. I find that that's going to be what I'm focusing mostly on in 2021, is coming up with online courses for data scientists.
Oh, that's so awesome. We're going to have to, I mean, I'm creating now a course for teachers called Uncommon Sense Teaching, and that's based on the book that's coming out in June. But it's on the neuroscience of learning, but it's for teachers. So it talks about some of these kinds of things, like how does learning a language and using the procedural system help with learning when you're learning coding or something. So I think what you're doing in moving into the online teaching world, that is just so awesome. You're going to have great fun, and anything I can do to support you, just let me know.
Yeah, definitely. I'm excited to I'll sign up for the course and read the book. And I mean, with online courses, it's more than just the creation of the course that you learn. It's, I have to market this thing. I have to drive traffic to it. I've got to create, good copy that will encourage people to sign up for the course. There's so much more to just the creation of the course that you learn, that I just found interesting. And again, this brings me back to this concept that you talk about in your book, and you briefly touched on it just now. This concept of transfer. So the ability to take what you've learned in one context and apply it to something else. Um, and this, for some reason, reminded me of people who are mid-career transitioners. You know, how the work that you've done in the past might not have a one-to-one correlation to what you're trying to move into now, but there's still some elements of that job that you can apply as you head to this new direction. So I'm curious how you've used transfer to your advantage during your varied career.
Oh, that's a good question. Um, I don't think I ever deliberately set out to use transfer, even though it's often there. It's more the idea that, um, for example, it's been bothering me for years. It's like, now, how come I've got this sense that learning a language helped me learning in math and science? I haven't really seen good solid write-ups about why that's the case. Why is that? And there was absolutely transfer in learning. My learning how to learn language helped me in learning how to learn math. So there was a real transfer going on there. But I think sort of stepping back and trying to look at it metacognitively and say, well, what precisely was the transfer that was taking place? That helped me to better understand. Let's see, how can I summarize this? Um, you have a learning pathway where you create long-term memories. And normally it goes from working memory through the hippocampus into your long-term memory. And that's how you learn declaratively. You learn facts, you learn steps in solving an equation. It's all boom, boom, boom. And that's what I've learned. But for really understanding unusual patterns that you can't really explicitly state. For example, how do you tie your shoes? You're learning a complex pattern and it's pretty hard to state it. And the complex patterns of language and so forth, you're using your procedural system to learn those. And that's going through the basal ganglia and up to create new sets of links in long-term memory there. It turns out that when you're drawing from information in your long-term memory, you need to have a double set of links. You need to have on the same material. I mean, you can do it with just one set of links, but you're like limping. If you learn a language and you know it declaratively, then you can explain, for example, the grammatical structure of how you conjugate a verb. If you learn it procedurally, you can just conjugate it without even thinking about it. If you learn how to type on a keyboard, you're learning procedurally. So you can do it really swiftly without even thinking about it. Things you learn procedurally, you can do without thinking about it and swiftly. And so you need to kind of cultivate both types of sets of links, because they both contribute to you be able to think both swiftly and flexibly about whatever you're learning. And so let's see, how did we circle around to this? What was the original question?
Well, the original question was how you use transfer to your advantage in your career. But that's an interesting point there about procedural type of learning, though. It's like, for example, like some people learn how to solve a algebra equation one way, right? And
Right.
if they only ever learn how to solve it one way, they just memorize that one way, and they're not able to abstract to the general, I guess, problem solving pattern,
Yeah.
right? And I guess that's one thing that I've noticed in my career being, I've worked in insurance as an actuary, worked in clinical trials as a statistician, and, e-commerce as a data scientist, just being exposed to a bunch of different problem statements. has given me an ability to match strategy to problem type. And I think, I don't know if that's transfer at work, or if that's just being exposed to a bunch of different types of problems.
I think that's the kind of deep mastery that occurs when you've learned both ways really well. Because sometimes stuff will just come to you quickly. You'll look at something and you go, oh, well, that's this. And that's in part arising from procedural knowledge that you have gained from just practicing with a wide variety of different types of data. But I guess what I was really kind of circling around to on that idea of transfer is that if you have lots of different backgrounds or fields or knowledge that you have gained in many different areas, that it can create new ways for you to look at the material, in part through transfer, that really fuels creativity in what you're doing. So I just think that's fascinating that you've worked in so many areas that you've kind of begun to gain mastery on specific, so no matter, it's almost like no matter what angle somebody throws a ball at you, you can still hit it.
Yeah, because even these different job titles, the different industries, yeah, they're different, but at the core of what I'm doing, it's still just quantitatively rigorous work. And in e-commerce, we might call this customer churn, but in clinical trials, we call this survival analysis, right? And it's being able to step back and say, okay, well, these are actually the same problem. There's just different, I guess, context, different vocabulary terms that you're using to describe what's happening, but they're really the same problem. And just being able to make that connection, I guess, has been helpful for me. I guess helpful in creative problem solving as well. So I'd like to take a different direction now to talk about some of the more nuts and bolts of the book, starting with one of the first concepts you talk about, and that's the focus and diffuse mode of thinking.
Mm-hmm.
Can you describe these for us, and also describe how they work together to help us solve problems?
So I'll just start by saying part of the reason I fell off the math track when I was very young was I would look at the other kids. I was 7 years old, and they could learn the multiplication tables, and I just couldn't see the pattern or the use of it. So I just gave up. And it just didn't, stuff didn't come to me swiftly. But if I had known that it is perfectly normal the first time you sit down to look at something for the answer to not seem obvious, or for you to be unable to pick it out, or solve it, that's a very normal part of the human condition, I think it would have made a big difference for me even early on. It would have been like a vaccination. Oh, this is what's happening when I'm getting really frustrated. It's the fact that when you are focusing on a specific problem, for example, you can kind of think of it as using a small network in a specific area of the brain. But it may not get you to the solution. You may need actually this area that's over here. That's a different, slightly different set of neural links. Well, you can't get there from here. If you're really focusing on this one little area, you're stuck. And the only way, or the best way, to get yourself unstuck is to get your focus off what you're doing. And if you get your focus off, it turns out that what the brain defaults to when it's not focusing on something is called the default mode network. And what happens then is it's a very different set of of neural connections. And so you kind of have if you have a break, if you get up, go have coffee, or go to sleep that night, take a nap, or work on something very different, your brain goes into default mode network for part of that time. And all of that helps to give you a fresh perspective. And also during that time, consolidation processes are taking place. So it's like your hippocampus is kind of talking to the sets of links in long-term memory and the neocortex, and the hippocampus is trying to kind of figure out what the heck is she working on. So between the default mode network that helps you just look with a fresh perspective at maybe a slightly different area that will help you work the problem, there's also consolidation processes that are making sense of what you're trying to learn. And between the two of those, when you eventually return to the problem, as long as it's not so long that it's kind of fallen away, you can find yourself making, it's like, gosh, what a fluke. Now it's easy and I understand it. How come I couldn't see that before? And it's this transition from focusing to taking a break that's really important to help your brain. It's almost like you got to step on one foot, then you got to step on the other foot in order to move forward with the first foot again. So you got to go back and forth between those two different modes, and they're really an important part of learning. So I think for me, learning language again, I'd be like, oh my word, those Russians, they have such a weird way of saying or thinking about whatever. And of course, it's just not the way I'm used to. But then you practice with it for a couple of days, and then it's like, well, of course you say it that way. That's easy. It's these processes taking place in the background. And it's the same thing when you're learning coding, math, chemistry, whatever you're studying.
So I guess how do we so the way we would recognize when we're in one mode or the other is that, let's say when we're writing some code to solve some machine learning problem, like we're focused really, really intently on it, we're in the zone, we're typing away. That's kind of like the focus mode. And when we're, let's say, walking at lunch and just getting some air, and then all of a sudden, like the answer that we were looking for just kind of pops up in our head, that's when we're in the diffuse mode.
Yep. And about the only time we're really, really consciously aware of what's going on in diffuse mode is when that answer pops to the surface. A lot of times we're really not aware of it. It's like a daydreaming, mind wandering sort of mode. And it's good and bad because it's often self-referential. In other words, you're like, what were they really thinking about me? That's anxiety, and it's also self-referential. What were they thinking about me? And so diffuse mode or default mode network can be the more anxious type of network, but it is also very definitely affiliated with creativity. That's where a lot of the scientific and other creative breakthroughs come from. And in fact, maybe I shouldn't say this. Well, there is evidence that if you can suppress focus mode by, for example, being very tired or being drunk. And so it kind of shuts down your prefrontal cortex. And there is evidence that you are more creative when you're tired and when other sorts of things can, and when you're indulging in other things.
It's interesting. I was interviewing somebody last year, Alex Pang, who wrote the book Rest, and he talks about how a lot of creative individuals throughout history, they are able to just go for a walk and have these creative breakthroughs happen. And I guess that is kind of that the diffuse mode at work. But how do we tell when it's time, right? Like how do we know that, okay, this is really draining. I need to switch this up and get into the diffuse mode. Are there any things that we should be kind of mindful of when we're working on something that, okay, it's time to take a break?
Well, there's always this back and forth of, how soon does what you need to get done need to be done? And so one must always be mindful of, uh, some crunch time, and crunch time just may not leave time for breaks and so forth. But I think most, the biggest clue that something is, that it's time to take a diffuse mode break is that you're feeling stuck on something. Now, one thing they often tell us, like, I'm a big fan of Cal Newport's work, and he wrote the book, of course, Deep Work, and it's about really focusing and not being distracted by externalities so that you can really deeply get into a subject. But it turns out that that's not the complete solution, because what can happen is you can end up becoming fixated on an idea that's a wrong idea. And then if you just keep diving deeper and deeper into it, you're going the wrong way, and you can't get out of it until you take a break. And so I have noticed myself, I'm always like, okay, I'm going to focus really intently on something, and I'll get a lot done during that time. But other times I don't make myself focus 100%. Like if I'm writing along, and then I'll find myself, gosh, I just don't know what word to say here. I don't know how to get that down. And so I'll go do a quick glance at my email, which of course they tell you never to do. And then, oh, there's nothing there. And I'll come back. But even that little break is enough to get me out of that fixation. And I'm able to, oh, yeah, of course, it was this, And so I think there's this yin and yang of, yes, going deep, and deep work and not being distracted is really important, but also being aware that sometimes it's okay to be distracted. There's evidence that, for example, working in a coffee shop can be helpful, because those clank of, don't we wish we could all be experiencing coffee shop work, but that there actually are apps of coffee shops, but that little clink and clank can draw you momentarily into the diffuse mode or default mode network, and allow you to think more creatively about what you're learning or what you're trying to work on.
It's almost like a fine line between diffuse mode and distraction, right? Because I find myself sometimes, I'm working on something, and I'll just distract myself by going on LinkedIn real quick, check my email address, check my download numbers, and it's almost like a compulsion to do so, and it's hard to kind of resist that, because I know that I'm checking those things not because I need a break, but just because I'm addicted to social media.
Right, right. Well, I think it does work, though, to have sometimes when you work and don't allow yourself to take these little random breaks occasionally, but sometimes to work and do allow yourself. And very interestingly, meditation, there's two fundamental different types of meditation. One is focus mode, which enhances your focus mode, and the other is open monitoring, and that enhances more default mode network. And it turns out, I don't know whether this is true for the open monitoring type, but if you are really big time into focus mode meditation, there is some evidence that it can suppress your ability to activate the default mode network. So it may affect your ability to be creative, in the sense that your default mode is suppressed more. But on the other hand, it can sometimes make you more creative, because you're less anxious if you're not activating that default mode. So depending on you, it might make you more or less creative through focusing or
Yeah.
focus meditation.
Yeah, I do two types of meditation. In the morning, I'll do like 10 minutes of that focused. And then in the evening, I get an hour to myself where I just do completely nothing, and I just sit and I just monitor the thoughts that happen in my head. Like I put no effort into stillness, no effort into monitoring my breath, whatever. I just sit, and I just sit with the thoughts and let them just bounce around in my head. And I like the second kind more better than the sitting and focusing and trying to still your mind. It's a lot less effortful to do that. So there's a couple of networks I always hear about in the brain. Um, there's the default mode network that you talked about, and then there's this reticular activating system. What are the differences between the two, and I guess what effects do they have on creativity?
Well, I'm not a neuroscientist, although I play one on TV, sort of. But the reticular activating system is more of a foundational system that is involved in whether you are awake and aware and sentient. So, for example, when I was working on the book Evil Genes, it was really an effort to better understand my sister Carolyn, who had some very deeply pathological behavior. The full name of the book is Evil Genes, Why Rome Fell, Hitler Rose, Enron Failed, and My Sister Stole My Mother's Boyfriend. And she did. And you're kind of thinking, how could anybody do something like that? Well, when I really researched from back in the 1940s when polio was ravaging the country, my sister was one of the last of the kids who got polio, and she was in an iron lung for months, and it pretty much destroyed one of her legs, and then she. But it turns out, and my father had said, she was a different person after she got polio, which is when she was like 3.5 or something. And what polio can do is it can affect the reticular activating system. So that's why you pay attention to things or don't. And so my sister did like this. So she ran away from home when she was about 19, and she was gone for 10 years. And my parents were frantic, but it wasn't like now where you can look people up very easily. And then after 10 years, she wrote my father and said, I'm so sorry for all the problems I've caused. I want to come home. So he sent her the money to come home, and she spent it on something else. So he sent her the money again. She spent it on something else. She had good excuses. So he got smart, and he sent her plane tickets. And then she came, and I remember her, hugging me. And she's, oh, Barb, my long-lost sister, I'm so glad to catch up. You're so special. You're really the very best. And I want to reacquaint with the whole family. And we talked for about 50 minutes, and then she went off to the store to get some things, and she met a man, moved in with him, and I didn't see her for 5 more years. So you think, how could anyone do something like that? But the thing is, remember, her attentional system, that reticular activating system, was messed up. I wasn't in front of her when she's standing in front of that guy in the store. So it's kind of like, I'm just out of the picture. And so the default mode network, on the other hand, it involves all sorts of different areas of the brain that are interconnected in a way that they're not connected in when you're focusing on things. So it's a very different, it's a network involved in often you're not conscious of the kinds of thinking going on there. But the reticular activating system is a much deeper network, and it's involved more in, the basic things that keep you aware and alive, from what I understand.
Yeah, it's really, really fascinating. I guess that's the reason why if you buy a new car, all of a sudden you see that new car everywhere. That's part of that reticular activating system, I guess.
Right. And yeah, that's something I really want to focus more on in future work, is just because if you, even in teaching, like when you're creating online courses, sometimes it bugs the heck out of me because educators will be like, well, we've got to have the students engaged. we've got to have ways to talk to one another. That's engaging the students. And so that's the most important thing. And then they'll slap these crappy videos, if they even bother to create videos. So slap them online and then put in a discussion forum and ask students to talk to one another. And it's like, why should they even bother to engage if you can't even get their attention in the first place with quality materials? So I think, before engagement comes attention. And that's where quality online materials really come to the fore.
Yeah, I definitely agree with that. So I'm curious because you've got such an interesting, combination of experiences and the stuff you research, your writing. We talk about creativity here as well. So what would you say is the difference between art and science?
Oh, let's see. They meld into one another. I mean, Santiago Ramon y Cajal, my hero in science, he was an artist. He was a wannabe artist. And of course, his father, it's funny, in the 1850s in Spain, fathers are pretty much then, they were then as they are now. No, you can't make it as an artist. I want you to be a doctor. And so his father was very deeply resistant to him doing anything with art. And yet when he decided to study medicine, he brought his love of art in, and he drew these. He could really see perceptively what was going on, and draw it and allow others to see what was going on. And from his very perceptive observations, he could kind of figure out which way neurons were sending signals. So his love of art allowed him to see more perceptively and shaped his science. I think in part, I suppose one could say that science has more math flavor to it, although it sort of depends on the discipline. But then you look at Leonardo da Vinci's art, and that was math flavored too. And that's part of why he was such a brilliant artist. So, I guess there's a melding between the two. I do like to think that having a bit of a background in math can help you in all sorts of things in the modern world. Either if you're studying art or you're studying sciences or anything in between.
What role does creativity play in science?
Sometimes none. Some researchers just have a kind of a formula they follow. They know that there's a difference. I think it was Thomas Kuhn who talked about sort of ordinary science, and then there's paradigm shift breakthrough science. I think a lot of really interesting and good science is, you're just like you take an idea from somewhere and you apply it in a very fresh way to whatever you're working on. And you may be a surfer, and so you use that to inform your understanding of chemical reactions. That's what Kary Mullis did with his groundbreaking work in that won him the Nobel Prize in chemistry. So sometimes people have told me, I have no creativity. And I used to say, oh, that's just not true. But now I've come to realize, oh, no, some people are less creative in a particular area, but they may be really super creative in other areas. And I think it's maybe part of it depends on the way you have learned a topic. And also your upbringing. For example, if you have been brought up that what the teacher says is always to be respected, that can kind of, even if you would have in another environment been a very creative person, that can kind of cut off some of your creativity. I do notice that, like, I was at the Santa Fe Institute, and they were, someone told me, oh, they're a really tough crowd here. And, I was like, I gave my presentation. They were like pussycats, just easy questions. And I was thinking, I was laughing to myself because fourth graders, I'm not kidding you, they can be the toughest crowd around because they don't know what they're not supposed to ask. There's always this kind of, feeling of, when you ask questions, you never want to embarrass somebody. And so people often, unless they are intentionally trying to embarrass somebody, which is very rare, they'll restrict their questions to things they are pretty confident that the person can answer. But fourth graders don't know that. So they'll just ask you about anything. And then it's like, well, I don't know the answer to that, or you kind of punt or something. And so fourth graders, to my mind, are around the most creative, at least in the US, where I think we have some very good teachers who really encourage thinking more broadly.
Yeah, my son is 8 months old almost. And I'm excited for him to get to that age when he can ask fun, challenging questions that I don't know the answer to, because I think those are the most interesting type of questions.
Just wait, about 2 years from now.
Yeah. And you mentioned Thomas Kuhn, and that book is with the structure of scientific revolutions. Yeah, I've got that in my list of books to read on Audible. I haven't gotten to it yet. But I think in science, like, the creativity really, in my opinion, expresses itself with experiments and experimentation. Like, you look at some of these experiments that you have to do to test whatever type of cognition in babies, and you see how they devise these really cool, crazy experiments to test something. I find that to be just pure creativity to come up with these types of experiments.
Yeah, like most people would say, oh, Barb, you're really creative. You come up with these courses, you've got all these creative metaphors, you're able to teach these things. But if you put me in a laboratory and said, now figure out a way to learn this thing about babies, I'd be a complete, I look at experimenters and I'm just like, how did you think to do that experiment? I'm not very creative there. I'm like, probably zero creativity, or at most a skosh, but there's people who are way more creative, and then they would probably call themselves very uncreative as teachers or something. They could. So there's areas you're creative in, areas you're not so creative in, but it all has to do with experience and, levels of mastery, I think.
This might be kind of a hard question. It's kind of along the lines of, how do I know my purpose in life? But it's how do you find out what it is that you're actually creative at? You talked about how some people are creative in certain aspects, not creative in others. What can we do to help us recognize that, oh, actually, I'm creative in this way?
I think it's back to that opening question, or the opening comment. Lady Luck favors the one who tries. It's really hard to get an answer unless you're just kind of trying lots of different things. And then your internal procedural system will begin to deduce patterns of what seems to work well for you. So I think just doing as you're doing, and trying lots of different things, while still having, you don't want to throw away your day job completely. You want to have some kind of mechanism for bringing in, something to live on, but continuing to try different things is probably the best thing that we could do without, since we can't really know the answer until maybe on the other side of the end of life experience. So
I like that. Yeah, just try a bunch of different things, kick up a bunch of dust, see what works, and make connections between things. Yeah, just through essentially just kind of hustle and motion. Um, I know that we are running longer time. Are you good for time?
Sure, if your
Okay.
listeners are.
Oh yeah, they are used to an hour and a half long podcast from me. I love talking to authors that I really admire about stuff, and I know the audience enjoys it as well. Um, so I guess the next kind of question I want to move on to now is just the relationship between emotional state and our capacity to learn things. What is that relationship? I found it that when I was uh, when I'm just like angry or upset or depressed, and I try to learn something, nothing sticks. So why is that? What is that relationship?
It's a very complicated relationship, and so I'm not sure I can do it justice here, and I'm not sure that I have the knowledge base to do it justice. But I will say that what I think is fascinating is that if we get curious about something, that so that there, people talk about dopamine, and that relates to our motivation and so forth. Well, it turns out that dopamine has two very different effects. So there's phasic dopamine, which is like released in these little tiny pulse bursts, or by dopamine neurons, or they kind of dit, 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 dit. And then there's tonic dopamine, which is sort of released at a low level through more of your brain. It's kind of like Muzak when you're in a grocery store. It's kind of all around. And this tonic dopamine, those levels are what help you become motivated. So that's why when you might take, not that I'm encouraging this, because if you take something like Adderall, it can increase that tonic dopamine, and make you feel more motivated to work on whatever you're doing. The problem is, of course, if you do it very often, it changes the ratios of what's happening, and it can kind of monkey around with your ability to be motivated overall. So it's like a one-time deal. It'll help. Then the next time it'll help a little less and so forth, because it monkeys around with things. But you can see from that this, these kinds of dopamine levels, the tonic is what helps get you motivated for things. Phasic, on the other hand, that's released when you're curious about something and you get that. So like somebody gives you a hook, to a story. Like, I lost the ability to read and write when I was 36 years old. And now I'm going to talk about this related thing. Well, you're kind of sitting there going, yeah, but I want to hear about how you lost the ability to read and write when you're 36 years old. So you kind of follow along and you're curious this whole time. And then you get this stuff fed to you that they want to teach you. And then they tell you, this is what happened to me. I fell down the stairs or whatever. And you get this sense of closure. And what happens in that process is this phasic dopamine is released. And all those neural pathways that you've been using like over the last half an hour, that phasic dopamine, it kind of like sniffs out all your recently used pathways and it strengthens them. So it helps you learn. So if you get curious about what you want to learn, it can help. It actually helps those new neural links to cement together, especially once you get your curiosity satisfied. So, I think to me, that's a fascinating aspect of learning. And it shows why good teachers, for example, when you will be teaching online, one of the best things you can do is set a hook at the beginning. And as engineers, here's what engineers like to do. They tell the answer to the hook because you don't want to leave people hanging. So you just say, here's the hook, here's the answer, and then you go on. And it's like, no, that ruins the purpose of the hook. You got to tell them, set it, and then leave them dangling for a while. And this is something that is well known, of course, to marketers. It's big in the marketing industry. That wonderful book, Influence by Cialdini, talks a little bit about that in Persuasion, his subsequent book. But novelists really understand that. And if you look at good nonfiction writing, it has a hook, and then you got to follow along with it. And bad nonfiction writing is, here is the information about Neanderthals or whatever, and it doesn't hook you.
I want to get your opinion on how I get curious about new things that I'm studying. So let's say there's a new algorithm, whatever technique that I want to study, and I get a book on it. I'll go through the chapter first, and I'll just kind of skim through the chapter, look at pictures and stuff, and then just come up with some questions before I even start reading about this thing that I'm learning, so that I kind of prime the pump, so to speak, get myself curious to find those answers. Is that a good way to use curiosity to
That
help us
is
learn?
like the optimal way to use curiosity. That's fantastic. You couldn't do any better than that. So yeah, I love it.
Awesome. Um, so I found it interesting that we can change our brain by changing the way we think, which to me was just like, what? How's that? Doesn't your brain make you think? How can you change your brain by thinking? How does that happen?
I think that can be all sorts of different things going on. But for example, uh, Tom Sawyer was a very famous, Mark Twain wrote the book Tom Sawyer, and Tom Sawyer was this kid who was sort of a mischief maker, and he made some trouble at school, got kicked out of school, and then as his punishment, he was asked to paint a fence. So of course he didn't want to paint the fence. But what he did was, the other kids were coming by and asked him about painting the fence, and he's like, oh yeah, well, it's a very special sort of thing, and no, you can't try it. No, it's only for people who really kind of know what's going on. And eventually he worked it so they're kind of like paying him for the chance to paint the fence. So he completely shifted their internal motivations just by rethinking things. What exactly is going on from a neuroscientific perspective when that happens? All I can think is that change in how you're thinking about things is changing your tonic dopamine levels, those underlying levels, and just a shift there kind of shifts those underlying levels, and it can make it so that you become motivated for something that you were never motivated for before. And like I had that happen when I was in the military. I mean, I wasn't motivated to learn math and science, and then I can't get a really good job. And besides, I can actually see the use of this radio equipment with the group that I'm supposed to be leading, and I'm the village idiot in leading these people. It changed my motivation, and I'm sure it changed, that shift of how I'm thinking about things probably, just kind of monkeyed around with those tonic dopamine levels. And then that made it easier to be motivated to do it, even though at the beginning, you're still not sure you like it. And then, of course, once you get used to it, you start studying it, you start getting these occasional good grades. And then that's helping your motivation. And then you get curious about it, and that's helping your learning. And so it kind of plays back and forth.
What implication does this have for the way we talk to ourselves, our inner monologue, and our ability to learn?
Um, I think that our inner dialogue is far more important than many people ever think. Um, there's a book that I've just started on, how to get over negative self-talk. And it's a very good book, but we often talk negatively to ourselves. And I think it really does. There's plenty of evidence from behavioral therapy that if you change how you're thinking about things, like, for example, instead of thinking, that guy just doesn't like me, I know he doesn't like me, to instead write down, this is known as mind reading. I'm putting thoughts into what I think that guy is thinking, but I have no actual evidence for that. And writing all of that down can help your mind, like, oh, wait a minute, and break through that negative self-talk that you've been giving yourself. So I think self-talk is turning that into something more positive is a really important thing to do.
Is there kind of like a relationship between your self-talk and, your reticular activating system, or maybe even default mode network, where if you're constantly telling yourself like, oh, never going to get good at this thing, I'm so dumb, I'm so stupid, you'll just start finding ways to make that your reality, kind of?
I don't know enough to say whether that's related to either system, but I suspect it may be related to the procedural system, in the sense that, let's say your procedural system is often related to physical things, but now we're beginning to understand it's related to mental things too. But if you hit a ball a bunch of times, you hit it, then somebody throws a ball at you, you can just instantly react and you don't have to think about it. Or, like, let's say you're driving home, you can actually think about some other completely different problem as you're driving home and not be thinking about how you're suddenly home and you're like, how did that happen? It's because your procedural system took over, because you've done it so many times. It's a habit, sort of. And I think that when we self-talk negatively, it becomes this habit. It's a default way. And a lot of times we will give somebody ask us a question about why we're doing something or our thoughts of something, and we think we're answering in a logical way, but actually that answer is coming from our procedural system, and we don't have access to how it came up with these things. It's just we get the output from the procedural system. So I think when we're always feeding that procedural system negative stuff, it will spit negative stuff back out when we call on it, or even when we don't call on it. And of course, we think we're being rational, but we're actually not being rational, because it's coming from this invisible black box of the procedural system, which we have fed with, patterns and all sorts of things, for like bicycle riding, doing all sorts of other things, but also negative mental patterns.
I'm curious if this is at all related to this Einstellung effect, right? That if I recall correctly, that's when you're working on a problem and you're telling yourself that, yeah, I know this is the way to do it, I know this is the right answer, and you kind of lead yourself down the wrong path. And we kind of touched on that earlier, but is that at all related, or am I just like mixing things up?
No, that's a very interesting question. I don't know whether it's related, because it could be. I've never really thought of that before, because I've always felt Einstellung is more like, it's a little bit like function, or like fixation in your thinking. You're thinking in one way, but actually you need to be over here. But for example, the famous Pearson Pearson coefficients and so forth, the brilliant statistician, he was he was notorious for he would never accept that he was wrong about anything. And so this one fellow got up and gave a big speech in which he kind of pointed to some errors in Pearson's work. And by golly, several days later, that guy went into his office and it was destroyed. Somebody had got into it and just, like took a sledgehammer to everything. And Pearson was back in the day, like, what was it, 1920s, 1930s or something. And he's like the most preeminent statistician in the world. Yet he simply, and all evidence points to the fact that it was actually Pearson that went into the office and did that because he was so angry about somebody saying that he could possibly be incorrect. And of course, he was incorrect. But it just goes to show it. And we always kind of think these wrong scientists or, people who are unable to correct their errors in their thinking, that was only back in the day. But now in modern day, we just don't have that kind of thing. And it's all over. It's everywhere nowadays. It's just that people don't talk about it until those individuals are safely dead because, you don't want them doing the modern equivalent of wrecking your office, which is instead suing you, but there's just so much evidence, and I see it everywhere, in science, in education, it's in every field, because people, they can have a vested interest in whatever, there's motivated reasoning because your whole career, you may have been teaching one approach to how children learn or psychology or whatever you're doing. And if you accepted this other counterposing idea, it's kind of overturning your entire life. Some people can do that. There's one fellow, Hariri, at the National Institutes of Health, and he said, this study has come out, and it means that most of my work is overturned because it shows that it's a problem, and I was, I've always loved Hariri's work, and now I love him even more because he's actually willing to say, oh, gee, I've got to throw out a bunch of my work because of this latest finding. But that caliber of scientist is very, very rare, unfortunately.
Yeah, I guess it's okay to be wrong about things, right? Like you just have to accept that, yeah, I got this thing wrong. I didn't know what I didn't know. Now I know some stuff, and I have to update my beliefs and update my research in light of these new findings.
It's all Bayesian.
Yeah, it's all Bayesian. Exactly. I know what that's like. In the time of frequentists, I was a Bayesian. That was rough.
There we go. Yeah,
it
was rough.
Yeah, I went to UC Davis for most of my statistics, and it was a frequentist school of statistics, and I had left-leaning Bayesian tendencies. It was not happy times for me.
The latest book that I'm really enjoying, though, is Judea Pearl's book on
Book of Why? Is that the one?
Yeah, the causal analysis. It's a wonderful book, and he tells the Pearson story. So if you want to just see a nice, interesting angle on the newest things that are unfolding in Bayesian analysis, you probably already know these things, but it's just so important. Causal analysis it's thought to be that will be a key in how artificial intelligence will forge ahead. So it's a fascinating area.
Yeah, I tried to get him on the show, but to no avail. It's okay though. So we got the last question before a random round here. It's 100 years in the future. What do you want to be remembered for?
Helping to put education on a solid scientific foundation that really helps students to learn in ways that we know will help them to learn best.
I think you're well on your way to accomplishing that with all the wonderful work you've done and the wonderful content you've put out there. So let's jump into a quick random round here.
Oh, no.
They're fun questions.
Give me an easy one. Give me an
If
easy.
you were to write a fiction novel, what would it be about, and what would you title it?
Oh, for one thing, that's a really hard question because, like, I am the world's worst titler of books. I'll write them, but I can't. I'm pretty bad at coming up. Every once in a while, it's like, the clock comes around and strikes 12. Oh my goodness, I was right once. But mostly my publishers pick titles. So I will punt on the title. But I think I would like to write a international thriller of intrigue, where it's whatever it is, it involves travel to all sorts of different places in the world to figure out a fundamental issue. And but I have no idea what that would be. And I have great awe for thriller writers. So it's so hard just kind of keeping up with what's going on in education and learning about all sorts of different things that I think that's a career that I will handle in an alternative universe.
I think that's actually a good title, an international thriller. I forgot the exact words you used, but it was good. So, what do you think the first video to hit 1 trillion views on YouTube will be about, and when do you think that would happen?
It'll be a music video, and it'll have great dancing, and it will have love and super catchy tunes, and also end up with big groups of people all dancing happily together.
I love that. I love that image. When do you think that this will happen?
1 trillion views. Probably when maybe 50 years.
Wow.
I think we need a bigger population to get to 1 trillion views.
Yeah. This is part of my cohort study I'm doing. This is a question that I ask everyone, so I'm gonna take all the answers and see if the wisdom of the crowds will help us identify when.
I'm probably way too long, but then I'm a curmudgeon, so I figure if it's always best to have low key expectations. Then you can be surprised when things are better.
What song do you have on repeat?
What song do I have on repeat? Lately, I've had a little song that I'm going to use as the song that is the main song for Uncommon Sense Teaching, and it's called Practice Makes Perfect. And it's by a fellow named Zach, but I can't remember his last name, but it's on Storyblocks, and it's just a wonderful song. So I often, but that's one thing I'm very bad about, because when I listen to music, I really listen to music, but I'm often working. So that means I just don't have time to listen to music. And when I do relax, I'm reading books. So, and I'm not, you might say, well, do it when you're driving someplace. Well, when we're going someplace, my husband's usually driving and I'm working on the computer. So I don't have as much time to listen to music as I would like. I like techno pop, Euro pop, that kind of thing, and classical music. And I like some hip hop. So, there we go.
I like Europop as well, that techno pop. That's some of my favorite type of stuff. Speaking of reading, what are you currently reading?
Oh, so the Book of Why, a book on Neanderthals, which is telling me more detail than I ever wanted to know about Neanderthals. I'm like, has this author heard about the idea of giving just sort of a synopsis of some ideas, please, because it's like every single, and they did this. And then I just finished a book. It's a wonderful book what's the name of shoot? And I'm just going to write it up today. But it's this wonderful book on how this fellow tried to just start learning things. As a beginner. That's the name of the book, Beginners.
Mm.
And it's a wonderful book. And he talks about things like learning how to sing and voice lessons and learning how to surf and just doing all sorts of things as a beginner. And it's a great book. So I'm writing it up because I will tout it in my Cherry Friday next week. And then I'm just about to finish that book on negative self-talk. And see, usually I have like a number of books going on my Kindles. There's one on Fermat's last theorem. And my daughter is like, oh, you got to read this book. It's so good. And so I just started that, and she's right. It is really good. And I just finished this book called The Last Assassin. And it was about, Caesar's last killer who was left alive because Augustus was like not going to leave any of them. There were like 30 or 40 that were involved to some greater or lesser extent in the conspiracy. But it had the best beginning hook of any historical novel I've ever read. And it was that Paralysis, who was the last killer, he knows he's last and it's evening time. And he's kind of wondering what's going to happen. And he's reflecting back on the whole episode. And it was, all the killings, in the Civil War that ensued. It was the best opening hook because, of course, then you're curious all through the way, okay, what's happening? How is Paralysis going to get killed? He is, but how? And it hooks you really well.
I'll definitely have to add some of these to show notes. You're a lot like me, have a bunch of different books that you're reading at once. I just love getting information and ideas into the head and then letting them bounce around and collide with each other and seeing what happens with it. So interesting thing about Neanderthals, though, my wife's cousin got the 23andMe test done. And I think he has something like 2 or 3% Neanderthal DNA, which was 90% more Neanderthal DNA than anybody in the 23andMe database. I thought that was really interesting.
There's supposed to be, I read something and it wasn't published, and it probably wasn't published because it's not politically correct or something, but that some study had indicated that Neanderthals, that they seem to be affiliated with the genetics for learning math or doing math more easily.
Interesting.
And I thought, wow, boy, I'd love to read more on that. But, I'm not sure that study was published. And of course, it's a little, it's a sketchy area. But there is evidence, very solid evidence, that if you have trouble with, I wonder if he's like a night owl, because night owl behavior is more affiliated with having come from that Neanderthal gene pool. And it's thought it's just like they were up in the north, and you had these long periods where you didn't have light. And so it kind of skewed your night owl and day owl. And so it seems like Neanderthal genetics are affiliated somehow with, you being more of a night owl sort of person. And indeed, my colleague, who's Norwegian, and we're working on this book together, and it just makes me laugh because I'll be, it's 5:00 East Coast time. I'm done for the day. I'm going to now just turn to relaxing and reading and having dinner and so forth. He's just getting started 6 hours later in Norway. It's like, he's in prime time. It's 1:00 at night. Yeah, and he's got such a different, night owl mindset on everything. And I'm a total morning lark. Oh, it's 4:00. I'm ready to go. Yes.
Yeah, that's me. 4 a.m. In the morning. That's usually when I'm up. Daniel Pink wrote an interesting book about this chronobiology. It's called When, the Science of like
Yes.
perfect timing or something like that. It came out some number of years ago, but it was just a really, really good book. I really enjoyed that one.
Oh, Daniel Pink is a wonderful. He's a wonderful human being too. I
Yeah.
watched his master class course on it was on selling and so forth, and it just came out, and you feel like you're sitting there listening to your favorite brother or favorite uncle giving you really sound advice, and it's a wonderful class.
Yeah, he's one of my favorite authors. So I've seen the promo for that class, so I'm excited to carve some time out to go through that. But yeah, he is amazing. Um, Barb, where can people find you? How can they connect with you online?
Oh, if you just go to barbaraoakley.com, you'll see all my books and classes. And oh, and incidentally, there's the Learning How to Learn Massive Open Online course, which is free. They may ask you to get a certificate, but if you say no, then you can get all the course materials for free, just not the course certificate. But there's also Learning How to Learn for Youth, which is for kids. And there's a book that goes along with that. So it's like the kids' version of Learning How to Learn or A Mind for Numbers. And so that one is also similarly free on Coursera from Arizona State University. But all the books, all the courses and so forth are right there on my website.
I'll be sure to link those all in the show notes. Barb, thank you so much for carving time out of your schedule to be on the show. I know we went a little bit over than we anticipated, but it's just because I enjoyed talking to you so much. Thank you again for coming on the show.
Oh, my pleasure.